Hello and welcome everyone. Hope you're doing very well. Let's begin our today's session. We'll be starting with opening up Revit first. Then let's open up a new file, a new template, whatever you want to call it. Okay, this will do. All right, now let's see how we can open up Dynamo, guys. From the Manage tab, we can find Dynamo. So I'm just going to click on it. FYI, guys, when we upgrade our Revit software, our Dynamo software would also be upgraded. Now, obviously, when we say an upgraded software, we're talking about new features, we're talking about more items to work with, and later on we'll be discussing some of them, like, for example, the most important ones, and we're basically going to see how exactly this version of the software is different from the older versions. Now, as always, guys, before we begin working with the software, first, we need to become a bit more familiar with the workspace which the software provides us with. Take a look at this. The first segment is files. From new, we can create new scripts. Using open, we can open up older ones. Through using custom node, we can basically, personalize or customize a node to use in a project. You know what? More on this later on. We're going to circle back to this later on. The next segment is recent. Here you would find basically all the projects, all the nodes and scripts that you created and saved so far using your Dynamo software. The next segment is called backup, guys. This is actually very important because unlike Revit, or actually, you know what, it's better to say it in this way. We don't have this. Currently, we don't have this in Revit, but here we got auto save or, auto backup that we can use. We just need to specify a backup location in order to, somehow prevent working on a project from the scratch in case something ever happened to our system, for example. Yeah. Right, moving on to our next segment, which is called Ask. Here you can basically get help, guys. Like if you ever had a problem or a question, you can enter one of these discussion forums and ask other users or basically have a discussion regarding your problem. Or if you wanted to, you can even get some help from the Dynamo's website itself. Then we got references. Here you can go through some, video tutorials if you wanted to. Like, for example, we got some hints, some tips on how to work with the software. To be honest, I don't really think you'll be needing this, guys. Right? Next up from code, you can send out some of the issues that you might have. And after that, we got sample. Here you can check some of the pre-made samples that you get in Dynamo. And, this isn't really that useful, guys. All right, let us delve into this whole thing a bit further. I'm going to click on New here. Well, obviously, first off, exactly like in other softwares, guys, up here we got a menu, we got some different tabs containing several sub-items each, which we can obviously use based on what we need. To give you an example, currently the grids are off. I can go ahead and from View, click on Background 3D Preview, and then select Show Grid. Okay, now, guys, if you recall, in Revit, we got a segment called Quick Access Toolbar. To elaborate, in Revit, Quick Access Toolbar would contain some, you can say useful items and tools. Here we get something similar to that, guys. More specifically, up here, as you can see, we get some, icons representing useful items that we might actually need during a project. The next segment that we can talk about, and it is actually quite important, is called Library. Why it is important, though? Well, because basically Library contains all the items that you might need for working on a project, guys. Let me try to elaborate on this, guys. First off, all of these, headers, topics, all of these are called categories. For example, the geometry category or display category. By the way, each category has some subcategories. For example, all of these are the subcategories of geometry. To be more precise, for example, curve is a subcategory of the geometry category. By the way, guys, when we say curve in Dynamo or in Rhino, for example, or even in some other graphical softwares, we don't necessarily mean like a curvature. It might be like a two-dimensional sketch or even a two-dimensional line. I mean, if I click on it, as you can see, it has its own specific sub-items such as arc, circle, ellipse, line, polygon. So all of these can be counted as curves. To give you an example, I'm going to select arc. See, even arc has its own sub-items. For example, a 3-point arc or a center point arc and so on. Alright, moving on to our next point, guys. Funny thing is, Dynamo itself is kind of counted as a plugin, but it actually contains some plugins inside of it. However, we don't call them plugins anymore. Instead, we call them packages. And as you can see up here, we even got a tab for them. Now, basically, guys, packages are some specific scripted codes that have been added to Dynamo as plugins by other users. And exactly like other plugins, guys, they actually have an auxiliary role. To be more precise, instead of using several items in Dynamo for doing something, you can just use one of these packages or these plugins. Well, obviously, first you need to install the plugins that you want, and then you can find them here from add-ons. Now, currently, as you can see, this segment is completely empty. I've got nothing here because, well, obviously, I haven't installed anything just yet. And FYI, guys, the coding language by which these plugins are usually created, or, well, it's better to say scripted, are C# or Python. And you can easily find the plugins that you want on Google. Alright, guys, moving on. Exactly like in other graphical softwares, we got a viewport here. This is basically, where the magic happens. Like, this is where you would create, where you would display, or basically where you would script your codes. And that is why the viewport is called the main workspace. Alright, everyone, now let's try using our workspace. Let's do something, yeah. You know what, before we begin, though, let me do something else. Before we begin, let me give you another point, a complementary point, and it is quite important. Guys, when you open up the software, when you open up the Dynamo, from your Revit template, from your Revit file, it would only be for that file, for that template, and that template only. For example, currently, whatever we are going to do would only be applied for Project 1. Now, let me go ahead and open up a new file here. Right, wait for it. Now, let me bring back my Dynamo. Take a look at this here. It says Dynamo is not printing at the current document, meaning it only works for Project 1. Our previous document. See? It says Dynamo is now available. And guys, if we wanted to work on the new document, first we need to close down the Dynamo. And then from Manage, open up the software again. So again, guys, when you change your Revit file, or it's better to say when you open up a new Revit file, you need to close down the Dynamo once and then reopen it again. Oh, and by the way, here, if the Dynamo icon was disabled, it means that the software is already opened up. And obviously, you can open it from here. Here we go. Alright, so basically, guys, you just need to pay attention to the project on which you want to work or on which you want to use Dynamo. That is all. Alright, now, how do we begin our work in Dynamo, guys? The first step that you need to take when you want to work with Dynamo would be creating a node. What do we mean by node, though? Well, let's find out. Early on, we talked about the categories, subcategories, and some of the sub-items here. Each of these sub-items are called a node. For example, when we want to work with an arc, we say an arc node. When we want to work with a circle, we say a circle node. And then later on, these nodes would be connected to each other to create a code, or, to complete a process. So again, guys, we would begin our work in Dynamo by creating a node first. Now, most of the times, or usually in modeling processes, we would start our nodes by creating a point or setting a point first. The first node would be for a point. How we can do that, though? Well, let's find out. Let's see how we can set up our first node, which, as I said, would be for a point. Now, when it comes to setting the nodes in Dynamo, we got 3 methods, which I'm going to tell you all about based on their usage, meaning the first method is the most useful one, and so on. Now, the first way goes like this. I'm going to do a right-click. Here, I would see the search box, and in here, I can search for the node that I want. For example, point. So, I'm going to search for point here. Let me type it down. Point. Now, the nodes that we want to set have different modes to them. And this is actually the case in other softwares as well. For example, when it comes to setting a circle in AutoCAD, we have different modes such as 2-point circle, 3-point circle, and so on. So yeah, the same thing happens in Dynamo. In other words, before setting the node, I need to specify the technique that I want to use for setting my node. Now, the most useful technique that we have for setting a node, a node for a point, would be by coordinates X, Y, Z. So I'm just going to click on it, and the node would be added to my viewport. So again, I did a right click, then I searched for the node, and I selected one of these modes. And as you can see, we have a lot of them. And by the way, guys, mostly the most useful mode would be the first one, which, as I said here, would be by coordinates XYZ, which means that I need to specify these coordinates and I get my node. The second method would be searching for the node in the library search box. The difference in between these two search boxes is that when you type something in the library search box, you don't necessarily have to be completely accurate. Something approximate will do. To explain this further, when you search for something in library, it would kind of be like when you Google something. Even if you misspell something, Google automatically recognizes what you mean, what you exactly mean. So yeah, I'm just going to search for points here. And what's good about this method is that we can even get some sort of a description on the mode or the node that we're about to select. Yeah, I'm just going to select this and add this node here. All right. Now, as I mentioned a few seconds ago, guys, in this method, we can get some descriptions, which is quite useful because, well, let's say we just started our work, we don't have enough info, we don't know how the nodes work. So, in this case, we can usually use these descriptions. And, well, when we got enough info regarding the nodes, we can click on this icon to turn off the description somehow. So, the first method was right-click in the search box. Second method was search box in the library. Now let's talk about the third one. In the third method, we would basically just look for the nodes that we want using the categories, subcategories, and sub-items that we got in the library. For example, I still need a point, right? So, I'm going to click on the geometry here, then point, and after that, again, I can select the mode. Let me maximize my tab. See, again, by coordinates XYZ. I'm going to select this and it would be added to my viewport. Now, guys, these would be the 3 methods that we have for setting a node. Well, the first method is the most useful one because it's faster, that is all. And, well, it would be the method that we are going to use during our work. Alright guys, so we're done with the first step of our work. More specifically, we have successfully added this node into our viewport, okay? Now, in the next step, we need to somehow activate the node. We need to specify or add some values to it. To be honest, it's a simple process. We would specify an input, they would go through a specific process, and after that, we'll get an output. That is all. For example, the input that we need for point would be 3 values. One for X, one for Y, and the other one would be for Z. These values would go through a process, and as a result, we'll get an output as in a point. So, again, as inputs, or, well, aka ports, we also call them ports, we need 3 values. And after specifying the values, or actually after we specified the values and after the process is done, we'll get the point that we needed. Now, what kind of value we can set for the X, guys? Well, it could be a positive number, it could be a -1, or we can even go with 0. One thing that we need to keep in mind is the fact that most of the nodes have some predefined values for their ports. To prove this point, the node that we selected got set here without specifying any values, without specifying any input. What are the values though? Well, in this case, we got 0, 0, and 0. Let me show this to you. I'm going to move my cursor on the X. It says double, meaning the number, and the default value says 0. And well, we would get the exact same thing in Y and Z. So what we can get from all of this is the fact that if we didn't specify any values, any inputs, we'll get a point in the coordinates 0, 0, and 0. Now, let's change this, guys. Let's go ahead and try adding some specific numbers. So I'm going to do a right click here, and in the search box, search for number. So let me type it down. All right, take a look at this. We got number and number slider. Let's see what's the difference in between these two. I'm going to select both of them. I'm going to add both of them in my viewport. Okay. All right, guys, take a look at this. Number slider has a grip, has this handle to it that we can use to change up the number. For example, like this. This is quite, well, simple. But the other one is not dynamic. Using the other one, we'll get a fixed up number. So, guys, obviously this means that if we needed a fixed up number, if we needed a fixed up value or input for our nodes, we would use number. But if we needed a dynamic value, I mean something that we would change, we would go with number slider. For example, we would use this to set up a node for an opening or for a variable length. You know what, guys? Let me put this in more simple words. Usually, I mean, most of the times, when we are working with a parametric item, when we need a node for a parametric item, we would use number slider. That is all. But again, for setting a node for a fixed up item, we would go with number. Now, take a look at this, guys. In number slider, if I click on this icon, I'll get 3 more parameters. Let's see what they are. First, we got minimum number or the starting number, maximum or end number, and at the end, we got step, which currently is set on 0.1. This means that the starting number is 0, and the numbers would be increased by 0.1 each step. Now, I'm going to go ahead and set the step on 0.5. Let's check this one now. Okay. Next up, I'm going to set the step on 2, let's say. This way, we would only get even numbers. Okay, now let's try changing the minimum number this time. Let's say, for example, we need this node for something like a circle's radius. This means that we can't go with 0. So instead, I'm going to go with 0.1. This way, the lowest number, the lowest value that we are going to get would be 0.1. By the way, guys, when we are working with decimal numbers, do not forget to set the 0 before the points. I mean, take a look at this, guys. I'm going to go ahead and type down 0.1 here. The software would give me the 0 before the point, but sometimes this won't be modified. So we need to pay attention to this fact if we want to work as accurately as possible. Let me try to give you an example on this. 0.1. See, we'll get an error. So yeah, guys, don't let this simple modification that we saw here fool you. I mean, it won't happen all the time, so just try to work as precisely as possible. And well, honestly, it's not a difficult thing to do. You just need to get used to putting a 0 before the points when you are working with decimal numbers. Yeah, that would be all. Alright guys, now next up we need to connect the values to the ports that we have in the node. For example, I'm going to go with 5 here. Let's say I want to use this value as the input or as the port for the X. Doing so, I just need to click here. I'll get this, well, wire. I'm just going to connect this wire to the X. What has happened here is that the point has been moved forward on the X course by 5 units. Now, let's try number slider. I'm going to set this on 8.1. let's connect this one to Y, like this. Done. So overall, guys, the coordinates for my point would be 5 and 8. Now let's specify a value for Z as well. By the way, guys, we are able to use a single value for several parts. For example, I can use a wire here and connect 5 to Z. See? So now we have 5 for X, 8 for Y, and 5 for Z again. Oh, and as another point, guys, Dynamo does not have any independent unit system. The units and values work based on what we specified in, the unit system that we specified in Revit. So for example, when I say 5 units here, based on what I got in Revit, I mean 5 millimeters. Also, guys, if I change the unit system in Revit, Dynamo, this change would automatically be applied in Dynamo as well. In other words, it would be updated almost instantly. And again, guys, more specifically, this would happen based on what we would specify in Revit. Alright, guys, back to our own work. We successfully created this point. Now, guys, if I use my scroller to zoom in on the point, as you can see, the process will be done on the codes, okay? The thing is, viewpoints in Dynamo have two modes to them. Take a look at this item up here. It says Enable Background 3D Preview Navigation. And then this one says Enable Graph View Navigation, guys. So we call this mode Background and this one Graph. Further elaboration, in background mode, we're working on the codes, we're working with the codes, and in graph, we're working with the model itself. The models created by the codes. So when I click here, the codes become, translucent, and we would be able to work on the models. For example, now I can zoom in on the model itself, see? And not only zoom, I can use the scroller to pan, or for example, I can use the right click for orbiting. Obviously right click and drag. Yeah, this is some sort of a simple navigation process that we are able to go through in Dynamo. And we have some other items, such as zoom to fit. You can use this to get a complete view on a model, for example, if needs be. Then we also have zoom in and, obviously zoom out options. I don't really think you need to use them because you can just easily use the scroller. And we also got the rest of the navigating items that we talked about, such as pan or orbit. But as I said, you can just use the mouse. All right, back to background mode, and all the navigating items work on the codes, not the model from now on, guys. Right click has another usage here, guys. And zoom fit would give us a complete view on the codes. And by the way, guys, if you want to change in between these two, if you want to switch in between these two modes of viewports, you can just easily use the shortcut key, Control B. Obviously this goes without saying, but, just like in all the other graphical softwares, we need to get used to work with the shortcut keys because they would help us work a lot faster. And guys, by the way, Control B is one of the most useful shortcuts that we might actually use a lot during a project in Dynamo. Okay, let's work on creating another point now. So, another right click and search for point. By the way, guys, let me mention something real quick. When I search for point, as you can see, we get so many different items and sub-items. Well, the thing is, we don't really need to discuss everything, all the items that we would see all at once. We're not obligated to. And on the other hand, we're going to go through many different projects and examples. And we might not use any of these. So the question is, why should we discuss something that we won't be needing? More specifically, let's say we're working on a project in which we're not going to use any of these. We don't need any of these nodes. So why should we spend time talking about them? The thing is, guys, during the course, if we even leave a node behind, after you got completely familiar with the software, after you got, you can say predominance, You can just easily figure out what the nodes do, how they work, and, well, if you still needed help, you can get help from Google. So, to put this whole thing simply, guys, we're not going to go through all the nodes and, well, items, just the ones that we might need during a project. Alright, back at it again. Point by coordinates XYZ. Now, grab the code from its head and, for example, let's set it somewhere. Let's just set it here. Now, let's start specifying some values for the ports, and also let's go through a new point while doing that. The point is, generally, we have two types of numbers. We got decimal numbers and integers, guys. For example, 8.1 is a decimal number, and integer, as for integer, we got 8. And we also call the decimal numbers as well. So overall, we got numbers and integers. All right, let me show you the dictation here. I'm going to do a right click and search for integer. Take a look at this. We got integer slider. Guys, as you can see, we don't have fixed up integers. We only have fixed up numbers when we are working with, numbers or decimals. For integers, only slider. Right, now let's select integer slider and try comparing it with a number firsthand. All right, let me open up the codes. As you can see, they appear quite the same. Now, if you recall, for this step here, we could have gone with, for example, 0.1. But this is not possible for integer. Let me try. See, we can't go with 0.1 or, for example, 2.5. How about 2? See, this works. For the number, though, we can go with 2.5 or 2.1, for example. So basically, guys, the differences are not really complex. I mean, they are quite simple. And, well, based on what we need during a project, we can easily use either type of numbers, okay? Now, guys, let me give you a trick. Let me give you a cheat code. You can just simply use numbers all the time because they actually include integers as well. However, guys, there are some specific projects or some specific nodes in which you are not allowed to use decimals. As for an example, a division node. When you're working with such nodes, you simply have to use only integers. Otherwise, I mean, in case you used any decimals, aka numbers, you might actually make a mistake. I mean, during your calculations, for example. So not only using integers in such cases is recommended, is highly recommended, but also it's kind of a necessity, guys. All right, back to our own work. Let's try specifying these values. For example, for X, I'm going to go with 1. And then also for Z. And for the Y, I'm going to go with another one. I mean, a different integer. So I can either set up another node or copy paste one. You know what, let's do that actually. So select, Control C, and then Control V. Let's move this code a little bit and connect it to Y. Now, obviously, I can use a slider, this handle, to change the value. And well, I can do the same for X and Z, because they have the same value. What if I wanted a separate value for Z, though, guys? Let's see how we can do that. Select the wire, and then select somewhere on the viewport. Well, I mean, click somewhere on the viewport. See? It is quite simple. Take a look at this now. I can use a slider quite easily. Now, I'm going to set 1 for both X and Y. So as you can see, we are quite free to, set up the values however we want based on what we need in that project or example. Oh, and by the way, guys, as you can see, while I'm working with these values, I can see simultaneously what is happening to my point. Question is, how is this possible? Well, take a look at this. Down here, we have some displaying options. Right now, it is set on automatic, as you can see. These are basically the options that we can select for displaying the changes and modifications that we're applying. We got automatic, and also we got manual. If we go with manual, we would be able to specify when exactly we want to see the changes. If I select it, down here, this option would be added, Run. Now, if I change this, as you can see, nothing is being displayed. However, if I click on Run, the changes would be displayed. Let me reduce this. Run. Okay. Basically, guys, in large projects, we can't really use automatic. Because, obviously it's a large project. We might be working with hundreds of items and wires, for example. And in such cases, if we set the display mode on automatic, in each step, the software wants to display all the changes. Which isn't really logical, to be honest, because, well, it would simply be a waste of time. So it is better to just select Menu as a display option and then get on with the rest of the work, and, well, at some point we can check the whole thing and see what is happening. Now, there's another question here, guys. Before asking it, though, let me set another point here, such as this one. I'm also going to copy a slider here and connect it to the port here. Obviously, nothing is being displayed here because the display option is set on Manual and we haven't clicked on Run just yet. Now, we got several nodes here. Question is how we can figure out which one is being displayed and which one is not. Well, you might be saying that we can click on Run for that, but the problem is that does not distinguish anything. It doesn't, well, specify what I wanted. Well, the solution to our problem lies within a setting option, guys. Let's talk about it. In Dynamo version 2023, up here from the menu, we can select and open up Preferences. Then, in the General tab, we can find Show Run Preview. Let's turn this on. By the way, guys, here all the changes would automatically be saved, so when we're done, we can just close this tab. Now, back to the viewport, guys. I'm going to try changing this a little bit. And when I do so, as you can see, the wire turns orange. This color means that the code is not being displayed, so we can click on Run here. And immediately afterwards, the color, the wire, would have turned black. Let me show this to you again. Orange. Now Run. And black. Alright, now let's set up another node. Okay, new point. And as I said, we can use copy-paste. As you can see, the new node has not been recognized yet. Now, next step, give me another copy-paste. Set this here and connect it to this port. Again, guys, nothing has been recognized by the software. I mean, it simply is not realized that we have a new node here, but this whole thing changes when we click on Run just once. Doing this would kind of be like, well, we're just entering this new node into our workspace, guys. So this is actually quite important, guys. When you're setting new nodes, when you create new nodes, you need to click on Run at least once. By the way, guys, the menus that we have in this version of the software are a bit different from what we used to see in the older versions, and we're going to talk about them. Well, we're going to talk about the differences. Like, as an example, in the older versions, to activate Show Run Preview, guys, up here, we had to open up Settings first, and then in this list, we could have found Show Run Preview. Where is it? Here, we could have found Show Run Preview, and we could have activated from here. And by the way, graphically speaking, this is different as well. If I change this, for example, as you can see, the wire, the nodes, the frame around the nodes would have turned orange. And also, guys, the same rule about the new nodes applies here too. Like when we add the new nodes, we need to click on Run once. See, the new nodes are recognized. We got the orange color, and well, the rest is history. All right, back to Dynamo 2023 again. By the way, guys, some users believe that, well, the quality, the graphics were a bit better in the older versions. And to be honest, I myself am one of those people. But, well, what are you going to do? We need to be up to date. We need to move on with the world, no matter the cost. Anyway, guys, our next discussion would be regarding selection. For example, let's see how we can select several nodes together. For example, let's try selecting these 4 nodes. Well, it's quite easy. We just need a selection box. Guys, if you recall, in AutoCAD, for example, we had a concept called window crossing. We got a similar concept here. See, when the selection box touches the nodes, they would be selected, guys. So the nodes do not necessarily have to be engulfed by the selection boxes to be selected. Also, guys, let's see how we can add more nodes to our selection. For doing so, we can use the Shift key. We can press it and then hold it, and after that, we can select more nodes, and they would be added to our selections. Again, guys, we need to use the Shift key, not the Control key. It's going to work similar to Rhino. By the way, for deselecting the nodes, while we're holding the Shift key, we can just click on the nodes that we already selected, and they would be deselected. Alright, now let's talk about customizing our graphs, guys. Let's see how we can make our graphs a little bit more well organized. Up here, if I open up the Edit tab, first off, we would find Align Selection and its sub-items, and also Clean Up Node Layouts. By the way, guys, there are some similarities and differences in between the tabs in this version and the older versions of the software. I mean, regarding their locations, for example, and I don't know if I mentioned this before or not, but I'm not going to talk about the similar ones, guys. Regarding the differences, though, for example, in the previous versions, we don't have a tab called Dynamo. And as for the rest of the tabs, well, as you can see, they are pretty much the same. Anyway, as I was saying, guys, when we open up the Edit tab, we would find Align Selection and Clean Up Node Layout. Guys, cleanup is an automatic modifier. It automatically organizes our view by, for example, getting rid of all the empty spaces as much as it can. For example, I'm going to select all the nodes here and then click on Cleanup. See, it kind of compresses all the nodes. Now, I don't really recommend using this one, guys, because sometimes it might ruin the order in which you've set your nodes. And as a result of this, you might get a bit confused or disoriented when you try reading the nodes and, well, checking the codes, for example. How about Align Selection and its sub-items, though? Well, let's see. Let's say, for example, I want to align all of these nodes on the right side. So first select them, and then from the list, select right. Okay, let me just move these around a little bit first. Now, again, this time, left. By the way, guys, when I say left, I mean the leftist node, if it makes sense. I mean this one. Let me show it to you guys, actually. See, the alignment would be done based on the leftist item, or the rightist one, the top one, the bottom one. Depends on what we would select. Now, you might be asking, can we meet somewhere in the middle, though? Well, yes, we can. For doing that, we can select options such as X average or Y average. Let me demonstrate. For example, I'm going to select X average, and as you can see, the result would be something like this. And currently, I don't think Y average will do us any good. Yeah. Let me move these around again. I'm going to set these on the Y course. And now I can use Y average. See? Right, guys, the rest of the options aren't really that complicated, and, well, actually, they are quite obvious. You can just, well, go through them yourselves. You can test them one by one and see what exactly each of them does. You know what, let me just show you another one. Undo, and I'm going to select X distribute. Guys, this option prevents the nodes from being overlapped. Let me demonstrate a little bit better. I'm going to move these a little bit closer to each other. This is what I mean by overlap, guys. Now I'm going to select them and click on X distribute. It kind of creates some sort of a, what do I call this? A diffusion in between the nodes. In this session, we'll be discussing another node. We're going to talk about the arc node. Arc, and more specifically, the three-pointed arc, is one of the most useful nodes out there. For setting the node, just like before, I'm going to do a right-click in my viewport and type down arc. As you can see, we got many different types, many different items and sub-items, but the one that we are going to work with would be by 3-point. So I'm going to select that, and its node would appear. Now let's delve into this a little bit further. Let's see what kind of ports we have. We got first point, second point, and third point. I guess it's quite obvious. We just need to specify 3 points, and based on those points, an arc would be created for us. So the process goes like this: 3 points as the input and an arc as the output. So we can get that. We need a point node, guys. Let me set one here. Control C, Control V. A couple of times to get 3 points. By the way, guys, this is just a simple example. This is not a large project. That's why I set my display option on automatic. So I didn't want it to go ahead and spend time clicking on run each time I changed something. Again, guys, in larger projects, set the display option on manual. Now, for the values, should we go with number or integer? It doesn't really matter. We can go with either one. And we talked about the differences plenty before. If we wanted decimal numbers, we can go with number. And if we didn't, we can just select integer. So yeah, you're basically free to choose whatever type you wanted. I myself usually select or go with integer. So I'm going to do the same here. All right, so I'm going to set the node here. For the first value, let's go with 0. Or rather, no, for the x, let me connect this to x. And for the value, I'm going to go with 10, maybe. You can either use the handle or you can just type the number here. All right, so this will be the first point. Now, for the second one, I'm going to go with minus 10. So I'm going to set the node and type down minus 10. Connect it to x for the second point. Now, for the third one, again, Control C, Control V. Set the value on 5. And I'll be connecting this one to Z. Now, guys, assume that we have a crowded viewport and we don't really know which node belongs to which point. Well, in this case, by clicking on each node, its related point in the viewport would be highlighted. See? They get highlighted like this. Guys, I told you this point because when we are creating arcs, the order of the points are very important. I mean, talking about which one is the first point, the second point, and the third one. To elaborate, for example, let's say this will be our first point. Now, this will be the second one. And this one would obviously be the third one. Now, Control B, right click and drag, scroll to zoom in on the arc. By the way, guys, these navigation processes are very simple, but at the same time, they are extremely important. Now, let's try changing this a little bit. For example, I'm going to set this one as the second point this time. For doing so, I just need to select the wire and then connect it to the second point. Now, guys, in this case, we can't connect 2 wires to a port. So when we do this, when we set the wire here, automatically the other one would be disconnected. And well, guys, by doing this, we would work a lot faster. Now, connect the last point. See, the arc is completely different now. That's why I said the order of the points is very important when we are creating arcs, guys. Okay, guys, let's work on this arc a little bit further. Let's try changing it a bit more and go through more points. For example, I'm going to increase this number. Now, Control B. Let's zoom out a bit. Control B again. Now let's increase this one. Yeah. So we can basically change this quite easily. Now, guys, one thing that comes to mind is the fact that can we do something so that when we, for example, change one of these values, the other ones would act accordingly? Like, for example, the height would act or would change accordingly or would remain the same. Guys, when I say this, concepts such as, well, equations, formula, and mathematics comes to my mind. For example, can we come up with a formula? Can we design or specify an equation so that this point would always be fixed up here? Well, I say, let's find out together. For example, let's say I want the height to be equal to this all the time. Well, this one is quite simple. Just remove this node, and then connect this wire to Z. Done. Equal sizes, equal dimensions. Now, what if I wanted these two to be equals as well? Well, I could have used the same technique if the two values were positives. But obviously, this is not the case here. We got a positive number as well as a -1. So, what should we do then? As I said, we need some formulas. We need some equations in between the values. For creating that, we need to use a node called code block. Guys, this node is extremely useful, and along the course, we'll get familiar with it and its abilities more and more. Now, the first different thing about this node is the fact that for setting it, we don't really need to search for it. We just need to do a double click somewhere on the viewport. Here we go. We got the node. Now, the current formula that I need would be something like this. I need a value that would be multiplied or times a minus number, guys. So, we got the framework. Let's type it down. The first variable, let's call it A, for example, multiplied by -1. And yeah, that would be it, actually. Whatever A was, times -1. And this would be our equation. But remember, guys, do not press enter. Instead, click somewhere on your viewport. And this way, your code block would be converted into a node. See, it has a port here and also an output. You give it a number as the input and you get a symmetrized one as the output. So I'm going to remove this and set the code block here. This will be the port. So let's connect the wire. And as I said, as the output, we'll get a symmetrized number, which will be -17. Now let's try changing this again. All right. Now give me another copy as the value 5. Connect the wire, and then connect the output to Z. Now let's check this again. Good. Everything seems fine. Guys, code block is one of the most important parts or aspects during our works in Dynamo, so we need to become completely predominant in working with it. Now, let's remove all of these and work on a new example. Also, Control B, let's zoom in on this a bit. Control B again. I'm going to start with another point. Set the node here, zoom in on it. I'm basically going to add some nodes here, and then we're going to use all of them to work on another example for code block. Let's set a value for the X here. This will do, 29. Now give me another point. I guess I'm just going to leave this on 0. Give me another one in between these two. Now, guys, I want this point to be set in between these two all the time, always. So, how we can do that, guys? Excellent. We need to use a code block again. The equation would be A divided by 2. Now, for example, let's say the number here is 30. When we divide it by 2, we'll get 15, obviously. So first, connect the wire to the input here. Then, connect the wire to this port. Now, guys, no matter what kind of value I use here, due to the equation, this point would always remain in between these two. Now, let's specify a value for the y, guys. For example, you know what? Give me another code block. For the new equation, give me a divided by 4 this time. Now, let's connect the wire again. Connect it to y, more specifically. Right, let's check the result now. Guys, basically, this is how you can work parametrically in Dynamo. How you can create parametric models, complex parametric models. Now, for the z-port, again, we can go with another equation or with a fixed up value. Yeah, for example, 5. By the way, guys, we can use the code blocks to specify fixed up values as well. Take a look at this, 5. See, so we can just easily use a code block instead of using or setting a numbers node. As well, you can just basically set whatever you want inside the code blocks, guys. Anyway, as I said, I want the Z port to have this fixed up value, so I'm just going to connect this to Z. Now, another right click, arc. Then again, select by 3 points. Again, guys, as I said, to find out which points we have here, we can just click on the nodes and the points would be highlighted, as you can see. And as you can see, my arc would be this one overall. Now let's change this a little bit. Control B. Okay. Control B again. See, guys, Z is fixed up, but X and Y are variables. Alright, guys, I don't think this needs further explanations. You just need to keep on practicing and, well, somehow delve into the concept yourselves. The only thing that I'm going to do currently would be, well, discussing some small and complementary points. By the way, guys, in the future, when you're done with your practices, we'll be working on some sort of a project, or maybe more like an element. For now, though, let's just stick with discussing those complementary points that I mentioned. If you recall, as for the input for this code block, I went with 29, and I divided it by 2. Now, obviously, I can calculate the result in my mind, but what if I wanted to see it as well? For doing this, I can move my cursor on this item here. See, the result would be displayed. And this is exactly the same in all the other nodes, guys. For example, the point here. Or the other code blocks, guys. So you can see, the result would be some number. We don't have an equation for this one, so the result would be 5, obviously. I guess let's say we're in a hurry and we don't have enough time to spend on using this item each time, but still we want to see the result simultaneously. For doing so, we can go ahead and pin the result like this. Well, I don't think I need to say this, but we have this option in all the other nodes. See, we can pin the result. And now if I go ahead and change the value here, we would be able to see the results simultaneously. Okay. And again, guys, this works for all the other nodes. For example, let's try this point. If I click here, it says that we got a point with these ports, with these values. And obviously, by changing these values, the result would simultaneously be changed as well. Guys, basically, this is how we can have a better control on the outputs that we want to create. And by the way, as for the output or the result for this one, we only have an arc. Alright guys, moving on to our next point, we are going to talk about the different modes, different types, so basically different graphical types that a node could have. Talking about the different types of appearance that a node could have. For example, different colors, more precisely. Now, I've prepared an image for you and I'm going to use it to explain everything, guys. As I mentioned a few seconds ago, nodes could have different colors to them, and each color represents something, means something. Let's begin with warning, guys. This means that we have a problem. Either the node is not working properly, or it's not working at all. In other words, we won't be getting any outputs. Let me demonstrate. I'm going to separate the second point wire. Then use the same value for both the first point and the second point. As a result, we would be getting this warning and also this orange color down here. So the orange color below the nodes means that we have a warning. Yeah, exactly like what you can see in the image here. So you'll get this orange color down here, also the warning symbol, and you'll get a description or a note on what exactly is happening, what's the problem. But the thing is, you shouldn't really count on these notes for finding the problem because, well, sometimes they are not really helpful. Right, moving on, the next color represents a selected node. As you can see, a selected node would have this blue color to it. Right, let me demonstrate. When we have a blue color around the node, it means that the node is being selected. Next up, we can talk about two types. First, freeze, and the second one would be previews turned off. Guys, up to this point, we saw how we can create an arc through setting 3 points. Well, the result would be something like this, an arc, and we can also see the points as well. What if I didn't want to see the points though? What if I just wanted to see the arc? For achieving this goal, I can go ahead and turn off the preview for the points. I'm going to do a right click here and disable preview. Immediately after doing this, we'll get a gray color underneath the node. This means, the color means the result of the node won't be displayed in our viewport, guys. This is actually quite useful, guys. I don't really need these points here. They are quite interrupting. They are in my way. So, as I said, I can just turn off their preview to get rid of them. Yeah, they kind of serve their purpose, guys. We don't need them anymore. How about the other type, freeze? Well, this one kind of makes the nodes non-existent, we can say. They won't be getting removed or anything, but they won't be working either. Let me show this to you. I'm going to do another right click and select freeze. Now, when I do this, guys, something interesting will happen. What do you think it is, though? Let me show you. As you can see, the node and its output and its result would be deactivated. Both the point node and the arc node got freezed up, got deactivated. Well, obviously the same happens for this one. And well, for unfreezing the nodes, guys, we can do another right click and, well, deactivate this or unselect this, uncheck this. And remember, guys, up until the input nodes are freezed up, we can't really unfreeze the output node. Take a look at this. If I unfreeze this, the arc node would automatically be unfreezed as well. Next up, we got an active node, guys. Pay attention to these colors or these modes here. And also, we got other colors in other types or other states of nodes, guys, as you can see. Blue stands for active and red stands for inactive. By inactive, I mean that we haven't specified any, for example, inputs for the nodes yet. Let's see what we have in our viewport. For example, this one is an active node. All the ports are blue. I'm going to copy this one. Let me detach this wire. And immediately the port turns red. Even a single red port means that the node is an inactive one, guys. Now let's go back to the image. We have another type, another inactive, but this time inside the parentheses we have default. Now what does this mean, guys? We got no ports here whatsoever, yet the color that we can see is a blue one. Can you think of something? Let me ask my question again, guys. What kind of node has no ports to it, yet Dynamo displays it as an active one with these blue colors instead of these red ones? Guys, this means that the nodes are using default values. For example, for points, if you don't specify any particular values, they would use 0 as their default values. In an arc node, we don't have such a thing. We don't have such thing called default values, though. So unless we set a value for the nodes, for the ports, the node would remain inactive. Alright, back to the image. As our next type, we got error, this red one, guys, this red color. This means that we are going about something completely wrong. Well, I guess so far we didn't encounter this at all, so Let me see if I'm able to use one of the code blocks to demonstrate. Let's see what I can do here. I'm going to open up this code block, set several points, and then maybe a number. See, this is completely wrong, guys. It doesn't make any sense. That's why we got this error, this red color. Even if I use a single point, I would still get an error because, as I said before, we always need a 0 behind the points when we are working with decimal numbers. Alright guys, let's begin this session by discussing the circle node. To be honest, it's a very simple concept, guys. Let me press Ctrl B, and I'm going to use the right click, do some navigating to adjust my viewport a little bit better. By the way, guys, if I try doing the right click and set the node right now, as you can see, the software tells us that we need to switch to the node view first. So this is some sort of a reminder in case we, forgot to switch in between the views. Anyway, select, now right click and search for circle. Well, as always, we have different types, different items that we can work with, but the one that we are going to use would be the first one by center point radius. Meaning we need a point as for the center point and then a value as for the radius. So if I select this, in the node we would see two ports. One would be the center point and the second one is the radius, as I said. And we need a value for this. As I mentioned before, guys, some of the nodes have default values. And this is also the case here. I mean, as you can see, we have a blue color indicating that this node is an active one. And we can see a circle here as well. Now, let's check the default values. For example, for the points, we got geometry point by coordinates 0, 0, and 0. So by default, a point has been set in the mentioned location for the circle's center point. For the radius, the default value would be 1 unit, as you can see. And if you recall, guys, we said that, before we said that in Dynamo, we don't have an independent unit system. Instead, the unit system would have worked based on what we have specified in Revit. All right, now let's begin with setting a point here. Well, obviously we have 0 as the default values, but I'm going to go ahead and set an integer here, integer slider. I'm going to set this as my first port. And by changing this, I can move my circle from its center point. Now, give me a copy, then another value, which I'm going to set for the radius. Now I can change the radius here as well. Obviously, the radius can't be 0, guys. So let's do something easy. I'm just going to open this up and set the minimum number on 1. What if I wanted to go lower, though? We have numbers in between 0 and 1. The thing is, I can't do it here because this is an integer node. For decimal values, I need to use the number node. The number slider, to be more precise. Okay, now I'm going to go ahead and set the minimum number here on 0.1. For the steps, give me like 0.5. And yeah, basically just like this, I can set and also adjust my circle. Now guys, let's try combining what we learned today with what we learned in our previous sessions. If you recall, in our previous session, we got introduced to code blocks. We said that they have many different abilities, one of which would be creating sequences. And as for another thing, previously we also said that ports can get several values, however, only from a single node. For example, if I use this value, 7.1 for the radius, I won't be able to set another value from another node for the radius. However, I can use a code block to create a sequence of numbers and then use all of them for the radius. Let me try to give you a demonstration on this. First, I'm going to remove this one and then do another double click. Now, as I said, we can't use 0 for the radius. So let's begin from 0.1 instead. Now, from 0.1 all the way to, let's say, 5. Yeah, this will be the sequence. and some numbers in between these two. So give me a hashtag 6. So overall, we would get 6 numbers for the radius, 0.1, 5, and 4 other numbers in between these two. If I open this up, we would be able to see these numbers as well. See, guys? 0.1, 5, and 4 others. Now let's attach this to our port. Now Control B, let's see what we have. As you can see, this will be the result. Now let's try making this even more parametric, guys. How? Well, let's see. For the maximum radius, I'm going to go with R. And for the total number, I'm going to go with N. After specifying this code block, we can set some sliders for it. Let's attach the wires. All done. One slider controls the radius, the other one controls the number of circles. See? Simple, yet quite useful. Right, now that I mentioned the number of circles, let's actually work on an example regarding this concept. For that, I need more points, guys. I mean, if I wanted to add more circles. Like, for example, 10 center points would give us 10 circles, but 10 radiuses would give us 10 circles with the same center point, though different radiuses. So basically, we can add more ports here. Let me attach this one. And then move these aside. Let's see how many points we got here. 1. What I'm going to do would be removing this slider and set a code block instead. Let's say, for example, I want 3 circles each time. So let's see, starting from 0 again, double point, hashtag N, double point, 3, and yeah, that would be enough. This will do. Yeah, 3 will be fixed up. I'm going to add a slider to the ports here to get rid of the warning. Alright, now I'm going to attach this to X. With this, within the specified distance, we get 12 circles. Well, I can still control the number using this slider. So let's walk through this whole thing again. We have this circle node, If I set 17 points for the center point here, result will be 17 circles with the same radius, which by default is 1. Now question, what would have happened if I were to set 17 points, 17 center points, as well as 17 radiuses? Well, obviously, we would have gotten 17 circles with 17 different radiuses. Let me move these back in. Now attach this wire. Right. Oh, was this one? This one was the maximum radius. Let's reduce this and check the numbers. As you can see, we got a list of numbers that we're getting. So, guys, now we got 17 circles. And, oh, did I? Oh, I actually set this vice versa, sorry. So I'm going to reattach the wires. Now they are correct. 17 center points as well as 17 radiuses. Let's attach this and check the result. Basically, it's the same story in similar indexes. Let me open these two. Give you an elaboration on this. Here, the index in the first circle is 0, and its radius would be this one. And the circle with the index 4, for example, we get the proper radius for this index. Well, basically, this goes on and on. So as you can see, the output would be created pretty much automatically based on the indexes and their proper radiuses, guys. Now, again, I'm going to go ahead and reduce this a bit. I'm going to set this on 20, I guess. See, based on what we're doing here, the outputs would be created pretty much automatically and, well, completely accordingly. Guys, basically, these would be some rudimentary concepts that we as users should completely be familiar with in order to use them all in, for creating more geometrically complex shapes. Alright guys, now let's remove everything here and go through another example. I want to have several circles, guys, in different elevations and get smaller and smaller while moving upwards. So I'm going to begin with setting a point. Then I double click, give me a code block starting from 0. As for the maximum height, give me 30. And for the number, variable numbers like n. I'm going to attach this to Z. The next node would be integer slider. What am I going to do next? By now, you should actually be able to guess what I'm going to do next. Or actually, it's better to say predict. By now, you should be able to predict what I'm going to do. Okay? So, I'm going to open this up. Then, for the maximum, I'm going to go with 50. Then I'm going to attach this to this port and Control B. Zoom out. Done. All right, let me clean my workspace a bit. Again, as you can see, guys, the maximum height is a fixed up value. Now, we got the points. Now let's try adding or creating the circles. So first, set the node and then connect the wire. How many circles we have? 24. This means that I can actually create or specify 24 values as for the radius. So double click another code block starting from 0.1 all the way to maybe 5. Oh guys, actually I need to do this in reverse because this way the circles would get larger when we move upwards. So I'm going to remove this starting from 5 all the way to 0.1. Then again, as for the number, hashtag n. First, connect the wire to this port, and then connect this wire to the radius. This is exactly what I wanted, guys. 24 center points, 24 radiuses. And again, guys, we have the same index consistency or, well, index proportion as before here as well. For example, a circle with the index number 7 would automatically get the proper radius. Now, moving on to another point, something interesting. Let me see what's going to happen if I do this. Okay. We got a node that you might have actually heard about called shuffle. Guys, the shuffle node is a randomizer, exactly like what we have in music players. For example, when we set a playlist on shuffle, the music would be played without any specific order. We can say quite randomly, alright? Now, in our current example, guys, the circles are being created through a specific order. If I, for example, open up this list, and we try tracking the steps, as you can see, the numbers are gradually getting smaller and smaller, starting from 5 and going all the way to 0.1. So there's a particular rhythm to this, in fact. Now I'm going to search for the shuffle node here. I'm going to select shuffle list, not the other one. Now guys, this node, the shuffle node, doesn't really care about the input that you would give it, because it simply understands one thing and one thing only: randomizing. So, for example, if I attach this wire to this port and check the result. See? We can't really detect any specific order or rhythm because, well, there's none. Now that we have a completely shuffled or randomized list, let's create the circles. See? This is the result, guys. There's no specific order here. And honestly, this whole thing might be quite useful because sometimes during a project, you might actually, well, need such irregularities for specific designs. Who knows? And nonetheless, they are quite beautiful, in fact. Now, guys, we got another node for creating circles. Let me try to show this to you. Circle. Talking about this one, circle by best fit through points. Basically, using this node, we need to specify several points, and then, based on a calculated average, we'll get the best circle that could possibly be created through those specified points. Alright guys, let me elaborate on this. I mean, we're not in a rush or anything, so let's just move along gradually. The first node that I'm going to set here would be a point again. I'm actually going to set several point nodes and just create some random nodes, some random points, sorry. I'm just going to specify the ports, set up the ports quite randomly, nothing special. Set this scope block to all of these ports. I guess 4 will do. Yeah, that would be enough actually. Let's say we want to use these 4 points to create a circle. Now, first up, I need to create a list here. So I'm going to attach this wire. The order is important, guys. Next one. Not this one. The third one would be this. And the fourth one. Now, let's go ahead and set the node that we wanted. Circle by best fit through points. Let's attach the wire and check the result. See? This would be the circle. Now, I'm going to go ahead and do something else. Let me add another point here. For the X, give me, for example, give me 8. I'm going to add this one to the mix as well. Now let's check the result again. See, guys, somewhere between all the points. I mean, this is what I mean by the average, by best fit. Let's add another point. I mean, for the value, I'm going to go with -2. Then I'm going to throw this one into the mix as well. Let's check the result again. Here we go. By the way, guys, if we didn't consider the order of values, nothing drastic would happen actually. The model would be a little bit different though. I mean, different type of circle. So guys, the point here is the edge of the circles that we create doesn't necessarily have to go exactly through the points. I mean, exactly like what we saw in these few examples, guys. But again, sometimes it might actually go through the points, like in the first example where we had 4 points, okay? Alright guys, the next node that we'll be discussing would be the rectangle node. It is very important, quite useful, and it has some complementary points. Alright, so I'm going to start with searching for its node, rec. Well, again, we have several types, and the one that we are going to use would be by width and length. Now, in front of it, inside this parenthesis, we have plane, which is a new concept for us currently, and width and length. Let's select the node and see what kind of ports we have. Now, we got width and length, obviously. By default, they are set on 1. And there's another port without a default value called plane. And guys, we actually need to learn how to create a plane here. If you recall, in Revit, we had a concept called work plane. Remember that? This is exactly that. So, in fact, we need to learn how to create a work plane in Dynamo. Now, the thing is, there are actually a lot of usages for planes, for work planes, one of which would be in rectangles. Now, let's begin our discussion with a default work plane, guys. Now, as you can see, we got 3 axes here, X, Y, and Z. So, our current work plane, the work plane in which we have this grid is called, in fact, the XY plane. By the way, guys, from now on during the course, I'm going to actually ask you some questions. Try answering them. Well, obviously, I won't be able to hear you, but the thing is, I don't really care. The important thing here is for you to understand, to think, and to be active, all right? Anyway, guys, so back to our own work. So what do we call this work plane again? Excellent. We call this XY plane. Now, I'm going to do a right click here and search for plane, guys. As you can see, we have different planes that we can select. Or we can do something else, something even easier. Just directly search for XY. Here we go, the XY plane or the default planes node. If I go ahead and attach this wire, I'll get a rectangle by those default dimensions. Now, let's try another plane, for example, X and Z. Let me attach the wire and check the result. Here we go. And the last type would be Y and Z. Attaching the wire. Done. Guys, when you want to set your rectangle on the default plane, the XY plane to be more precise, there's a point that you need to consider. Well, in this case, you can use this node, rectangle by width and length. Using this node, you don't really have to create the plane anymore. Somehow the rectangle would be flattened on the ground. And then you can, for example, relocate it. You can move it around if you wanted to. But again, the point here is that you don't need to create the plane. Let me just add some values to the width and length here. Now, question, guys. As you can see, all of these planes are being set on the 0 point. Now, what if I wanted to have this plane in a specific height, in a specific elevation code? What do you think I should do? How can I get that? Well, as for one thing, I can't use these anymore. So, let me remove them. Basically, guys, when you have a particular location in mind for creating a plane, there's a specific node that you can use. The node is called Plane by Origin Normal, this one. Using this node, you would be able to specify the exact location in which you want to set the plane. So, let's select a node and delve into it. As you can see, as for the first port, we got origin. This is the point. As you can see, it says origin point of plane. The base point, we can say. The second port is called normal, guys, as you can see. In mathematics, we had a concept called normal vector. The normal vectors are the ones that are being set perpendicularly to the faces and planes. And here, we can specify the course or the exact axis in which the vector is being set. Right, now let's work on an example, guys. Let's say we want to set a plane within the elevation code 5. As always, first we need a point. Set the Z value on 5. I'm going to use a code block. And then attach the wires. Control B, let's check the result. Good. Guys, we haven't specified any normals yet. It's being set here parallel to XY plane. So obviously, we have a default value here. Let's check it. The default value is 0, 0, and 1. By coordinates 0, 0, 1. Obviously, the 1 is on the Z course. Guys, this is exactly the same as setting a Z-axis node here. See? There's no difference here. Now guys, on the same elevation code, we are able to specify different courses. Different directions. Let me try giving you an example here. Again, the same elevation code. For example, for the direction, the Y course. Let me attach the wire. Alright. Now, let's attach this wire to our rectangle. And this would be the result, guys. Some sort of a, we can say a vertical rectangle. And again, if I change the normal, the result or the output of the rectangle node would be different accordingly. So guys, up to this point, we learned how to create rectangles out of default planes and also how to set the planes in specific locations. However, the thing is, all the planes that we set up to this point were parallels to the global axis. I mean, sure, we can still move this plane upwards, for example, by 5 units, or we can move this around however we want, but all of these new locations are still parallels to the global directions. Can we do otherwise, though? I mean, for example, can we set a plane, let's say, diagonally? Well, of course we can. More important question, though. How? Let's find out how. For doing so, let me just detach this real quick. For doing so, we need a couple of points indicating the plane's course. In other words, we need to use a couple of points for creating a normal vector or a specific direction. Let me give you an example to help you understand this whole thing even better in a few seconds. Okay, so give me the point node first. Set the node here. Now, Control B. As I said, guys, I want to create, or I want to set a diagonal plane here. Diagonal how, though? Well, for further indication, I need another point. So, I'm going to set another point node here. Attach this wire. Control B. This is what I mean by diagonal, guys, for example. To make this even more visible, I'm going to add a line. Let me attach its wire. Here we go. Now, guys, do not mind this line here. Let's just remove it, actually. This was just for show and tell. That's it. How can we create a normal vector out of 2 points? Well, obviously, there's a specific node for that. It is called vector. Where is it? Here, vector by 2 points. Take a look at the image on the right. We have 2 points, and then there's a line and an arrow, an indicator arrow. So I'm going to select the node, specify the values that I need for the ports, which is not something crazy, and the result would be a vector. Now, by the way, guys, up here we have a node in which we were supposed to specify the vector. So I'm going to get a copy of this. Then I'm going to set the node here, attach this wire, and also let's activate the preview. Roll, this would be the result. And well, guys, if I go ahead and change this, the plane would act accordingly. For example, let's detach the X and specify another value like 3. It's basically the point somehow creates the vector, and the vector indicates the course of our plane. And what else we can do? We can attach this wire now to add a little bit of height to this whole thing. Or, you know what? I guess we can do something better. I'm going to set this rectangle node and then attach this wire. See, the result would be this diagonal rectangle. So guys, let's do a quick recheck. We said that rectangles need planes. We also mentioned that we have some default planes. They were XY, XZ, and YZ. You can select either one and create the planes based on them. Now, we said that such planes would always be set on the ground, and if we want to set them in a specific location, we can use the node plane by origin. Using this node, we would be able to specify a base point or an origin point, and then also we would be able to specify a normal vector to specify the direction. And it could be, we said that it could be on the X, Y, or Z. After that, our problem was the fact that these would always be set parallel to the global directions. And as a solution, we saw how we can use 2 points to create a specific direction or a specific normal vector. For example, 2 points such as these. For example, let's say this would be the direction that I wanted. And at the end, guys, we saw how to create a normal vector, a specific normal vector or a specific direction out of 2 points using the node vector by 2 points. And then, guys, after specifying the base point or the origin point inside the node plane by origin, for the normal port, I didn't use the default courses. I'm talking about X, Y, and Z. Instead, I use the one that I created using my new node. I'm talking about vector by 2 points. Then I got this diagonal plane, and after that I went on and attached the wire to my rectangle node, and at the end, this would be the result that I got. Now, we got another interesting point here, guys. The point is, other shapes such as circles and ellipses have the same ability. Talking about setting them on planes. Let me demonstrate. For example, I'm going to select the circle, set the circle by center and radius. The thing is, I can't set the circle on this diagonal plane here, guys. Not only that, I won't be able to set this on the XZ plane or even the YZ plane. By default, it would always be flattened on the ground, guys. Now, to be more precise, we can't do this whole thing using this node. There's another one, though, that we can use. Circle by plane radius. We want to use this node, guys. Instead of specifying points, we need to specify planes. For example, let me use this plane that we have here. See? Or, as for another example, let's use one of the default planes, which we don't have. So, let's have one here, XZ. Connect the ports. And the result. Yeah, so basically, this is another node that we can use for creating circle. Circle by by plane radius. Well, we have something similar for the ellipses. The node is called ellipse by plane radius. Yeah, basically, guys, these nodes are quite useful. When it comes to setting the rectangles, we don't have a non-plane node, though. Because as I mentioned earlier, we simply need the planes in order to specify the courses. So up to this point, we got introduced to the concept of planes. We also talked about the default planes. Then we created our own customized planes. And we went through some new nodes such as vector by 2 points. Then plane by origin and normal. Circle and ellipse by plane and... what else? Yeah, that would be all actually. Alright guys, in this session we'll be discussing the translate command. The equivalent command to this one in other softwares would be move. Yeah, basically in Dynamo, as for the move, we have translate. Now guys, remember, in Dynamo, we are able to basically get a copy from all the commands, all the nodes that we are working with. For example, the rotate node. Now, the translate node is not an exception. So in other words, we would be able to move and copy the nodes easily. Now, as always, let's begin with searching for the node and see what kind of ports does it have. First off, exactly like all the other nodes that we talked about so far, we have different types. One of the most useful types would be translate X, Y, Z, meaning moving the nodes on the default or the global axis. See what we have, as you can see, we got 4 ports here. As a default value for the X translation, as you can see, we have 0. So obviously, guys, first we need to specify these values for the XYZ axis, and then we need a geometry, we need a shape, an object. Now, as for the object, I'm going to go with something simple, like a circle. Set the node here. Guys, Control B, let me adjust my viewport a little bit better. Okay, back here again. I'm gonna connect this wire, and because we have 0 as the default values, nothing will happen. So give me a slider, an integer slider, more precisely, and I'm gonna set this for the export. See what happened? Remember, guys, this is not getting removed. I can do a right click here and deactivate the preview. It would be like we just moving this around, and if we activate the preview, it would be kind of like we're copying this. Now guys, exactly like in other nodes, we would be able to specify different values for the export. For doing so, obviously I need a code block from 1 to 10. step on 1. I'll get 10 numbers. If I attach the wire, the result would be this. This isn't something new, guys. We talked about this plenty before. We can use code block to create sequence of numbers. Now I can set the same thing for the other ports, such as Y and Z. I'm going to press Ctrl B and check this whole thing. Remember, guys, translate is one of the most useful nodes that we have. So we don't really have to use any vectors when we are using this node. For example, we don't need to work with these axes, X, Y, or Z axis. Yeah. So overall, this would be translate on global axis. However, what if we wanted to do this whole thing on a different course, on a more specific one? Well, by now you should be having some ideas, guys. Am I right? We need to use another node, another translate node. So let's just search for translate here. This time we need this node, guys. Translate direction distance. Now, as for the ports, again, we need a geometry. I'm going to go with the same circle as before. Then, as for the distance, I'm going to go with this integer slider node. Now the direction. If we set a z-axis for the direction, as you can see, the result won't be good enough. It won't be acceptable enough. And to be honest, it is not a logical choice. I mean, if we wanted to do this, we could have just used this node. See, we already have the X translation. But when using this node, it means that we need a new course. We need a more specific and different one. How can we create such a course? We need to be using a node that we discussed before, guys. What is it? Well, if you've answered vector by 2 points, you are 100% correct, guys. If you recall, for using this node, first off, we needed a couple of points. So I'm going to set this node here. Then give me a copy. Nice. Now give me a code block. 5. Attach it to X and Y. Okay. Next step, give me a vector. Then attach the wires to the ports. And at the end, attach the vector to the direction port. Currently, the circle only moves on the ground. If I attach this wire to the Z as well, this will move on the third dimension too. Anyway, this is how we can use vector by 2 points for creating specific and different courses, and then we can use these courses for translating or moving our shapes. Now, guys, the thing is, we can somehow create or do the same thing using our primarily translate node. Let me demonstrate on this. For example, this will be the geometry. And then as for the X, Y, and Z translations, just going to go with the same number, this value, this 5. Wait, I say this so hard. Anyway, there is another thing that I can do. Give me another code block. Give me another value here, like 7. I'm going to attach this value to these ports. Thing is, the direction I would get now would be a little bit more complex and different. Overall, guys, you can use both methods, you can use both nodes, but to be honest, the most useful one, I mean the one that you might use a lot during projects, would be this one. But well, if needs be, now you know how to use the other node as well, guys. Now, moving on, let's remove these, and then give me another circle. Set a node here. Then again, translate. Translate X, Y, Z. Now again, connect the geometry. Code block 5. Attach this value to X and also Z. Guys, as you can see, I got 2 shapes here, 2 circles. I want to use these 2 shapes to create a volumized form. So, the command that comes to mind for this would be loft. However, there is a point that we need to consider. If I go ahead and search for loft here, as you can see, we got different types. It doesn't matter which one we select. For example, give me this one. Guys, the thing is, we only have a single port here. So what should I exactly use for the input? Should I go with this? Or maybe this one? Obviously, when I do this, the other wire would be detached. Guys, let's think of our previous examples real quick and what we exactly had in there. Previously, all the circles were the outcome of a single node. Let me show you what I mean. Moving these out of the way and search for point. This is a very important point, guys, so pay attention. I'm going to try creating all of these circles. Take a look at this. We got several circles created out of a single node. The list that we got here, this sequence of numbers, proves my point. What we got now is different though, guys. I mean, one of the circles is here. Oh, no, but let's just put it in this way. We don't have a single list. Well, the condition that we need for using or working with lofts would be having a single list. But again, this is not the case here. These are completely separate. So, what should we do? What's the solution? Well, we got a node that we can use called create list. I'm going to do a right click and search for list. So it's the first one. Let's create. I could have searched for create as well, but if I were to do that, the item that we needed would have been set second in the list. So obviously it's easier to search for list. Now let's go ahead, select the node and see what we can do with it. Basically, guys, using this node, we would be able to gather several objects from several nodes or several lists into a single one. Into a single list. Now, in our current example, we got two objects. I'm going to hit this plus symbol and add these two more items, and then attach these wires. Now, let's say, for example, the output of this node is like 50 circles, and this one is 100. After attaching the wires, we'll get a list containing 150 circles, guys. So, overall, let's create with a combine several lists into a single one for the nodes that have a single port. Now, take a look at this. If I attach this wire, the loft would be created and we'll get the volumized object that we wanted. Now, in order to convey this whole thing better, let's go through some more examples. Okay, so as for our next example, let me find a reference file, a reference image. I guess this will do. Let's see what we have, guys. We got 3 rectangles here from 3 different lists because we have 3 different sizes, actually. To explain this further, due to the size difference that we can see here, we would realize that we're dealing with different lists. So again, we need to combine their lists. All right, so let's go back to our viewport to Dynamo and begin our work. Let's start with setting this rectangle here for its plane. Go with a default XY plane. For the dimensions, give me 5 by 5. Now guys, for the next one, I'm not going to go ahead and set up a new point up here, then the new plane, and after that the new rectangle. Instead, I can use a node that we discussed before. What? Translate. I'm going to try moving the rectangle. Translate XYZ. I'm going to attach this wire. And then, let's say, for example, I want to move this on the Z-course by 20 units. Or maybe less, like 15. Yeah, I guess this is better. Control B. Now, as for the third or the middle rectangle, we don't have a choice. We kind of have to go with a new rectangle. So I'm going to copy paste this node here and attach these wires. What we got in this code block? 5. How about here? 0, 15. What's the midpoint? Well, it would be 7.5. So give me a point here. Then for the Z, I'm going to go with 7.5. And then I need a plane in the same elevation code. And then at the end, give me the rectangle. As for the dimensions, this one should be smaller, so give me 2.5. So overall, I would get this 2.5 by 2.5 rectangle. Alright, let's do a quick recheck, guys. First, we set a rectangle on the ground using a 5 by 5 default plane. Then we moved that upwards on the z-course by 15 units. Then we found the midpoint, which was 7.5. We added a point in there. We set up another plane in that location. And then at the end, we created a 2.5 by 2.5 rectangle out of this newly created plane. So guys, in fact, we have 3 separate or different rectangles here. I mean, we have 3 different nodes. We need to combine all of these 3 nodes or 3 lists into a single one and then use them for our loft. So again, right click, search for list, and select list create. We got 3 nodes, so give me 3 items. Oh, and by the way, guys, remember the order in which we connect the ports is important here. You know, kind of like what we had in Arc, if you recall, I mean. For example, this will be the 0 item. This will be 2. And then this will be item 3. Now, as you can see, all of these are gathered into a single list. Now right click, search for loft, set the node, and attach the list to our loft's port. All done. Now, if you recall, I said that the order is important, right? So let's go ahead and change the order. More specifically, I'm going to try changing the order in which I'm connecting my wires or the ports. For example, first one, then the second one, index 1, item 2, okay? And item 3. Let's check the result. See, Control B. We got a completely different form now, kind of like a flower pot or something. So basically, guys, when you're working based on a specific reference, the order in which you connect your ports and create your list is quite important. Guys, up to this point, we discussed nodes such as translate or rotate. Why not discussing mirror then? Yeah, let's do that. Because if I'm not mistaken, mirror would be the last transactional command that we have in Dynamo. Yeah, guys, so without any further ado, let's begin our work regarding the mirroring process in Dynamo. Let's say we got a point here, such as this. Give me a copy, then a code block. As for the X, give me 10, also for the Z. Then next up, let's throw a line in there, like this, in between these 2 points. Guys, what I want here is to somehow symmetrize the line based on the vertices that we have on its endpoints. You know, as the result, I want a couple of, you can say, reverse V-shapes. So let's get into it. Let's see how we can do that. Now, as always, first, let's begin with finding the node that we want and check its ports. So right-click, search for mirror. Guys, use this one. I mean, this one that has this drop symbol. The other one works a bit differently, has a different system to it. Later on, we might discuss it. Anyway, select. For the ports, we got geometry, I mean, the object that I want to mirror, which would be this line. As for the second port, we need a plane, guys. So this would be another usage that we have for planes. Guys, what do you think will happen if I go with a simple default plane, like an XY plane? Let me set one here. And then I'm going to use it for the mirroring plane. See what happened? Now, how about I go with YZ this time? Let's set this plane here and check the result again. Good. And the other default plane would be XZ, which is not useful, guys, in this case. And if I go with it, nothing will happen. Alright guys, now let's try mirroring this line based on this point that we have up here. For doing so, we need a plane in this specific elevation code. So let's see how we can do that. Again, search for plane. Plane by origin normal. I'm going to set this for the origin point. And as for the direction or the normal vector, go with y-axis. Or rather x-axis. Right, now I'm going to use this plane as the mirroring plane. Okay. So I can get a copy of this. Then, for example, I'm going to use this object. Or rather, I'm going to try mirroring this object based on the YZ axis. Now, let me ask you a question. How can we mirror both of these simultaneously? Did you get it? We got this, what we can say, upside down V form. How can we set the same form on this side, guys? And again, the process should be happening simultaneously. Well, it is quite simple. We just need to connect both of these objects to our geometry port. However, as you can see, we got two separate nodes here. So what should we do? Great. We need to create another list. First, set both of these into a single list. Then connect the list to the geometry port. And then we need a YZ plane. Let's connect the wire. Done. So again, guys, list create is one of the most useful nodes that we have in the software. We just used it again, this time in mirroring process. And again, guys, I can basically add as many items as I want. I mean, if needs be, though, like, we shouldn't overdo this. Like, these are extra, that's why we got an error here. So I'm going to hit this minus symbol to get rid of all the extra items. Done. The next node that we're going to talk about is called Shift Indices. It has a long name to it, so let's just call it Shift, guys. What does it do? It basically relocates or reorders the indices that we have in a list. As an example, let's say we got a list here containing numbers from 0 to 10. For example, something like this. You know what? From 3 to 15. I don't want the indices to be the same as numbers, guys. Alright, anywho, we have a list like this. As I said, using this node, we would be able to reorder our list. Question is, how? I'm going to connect this wire. Next port is called amount. Here, we need to specify a number. For example, 1. Let's connect the code block to our port. Let's check the result now. Open up the new list. Guys, as you can see, by setting the amount on 1, the last index would be relocated to the top of our list. In other words, we can say that the previous last index would become the first one. Now, to help you convey this whole thing even better, imagine a deck of cards. Now, shift by 1 means that we take the bottom card and we move it all the way to the top of the deck. So again, the last card would become the first one in the pile. Now, if I set the amount on 2, this time, the last 2 indices would become the first ones. You know, it's kind of like repeating the previous process 2 times. See, we have 15 here first, and then we got 14. And now 14 is our first index. Now, what if we give the amount a minus value? Like -1. I'm sure you can guess this. First index would become the last one, guys. Kind of the same process, only in reverse. And yeah, guys, that will be all for this node. This node is extremely useful, guys. I mean, honestly, we're going to work with this a lot during our course. you know what? Let's begin our work now. Let's do it right now. Let's try working on an example to help you understand this whole thing further. Take a look at this, guys, this image. As you can see, we got 2 rows of points, and instead of creating parallel connections in between the points, we set up the connection in a way that would give us this crisscross form, guys. So, in fact, in this row, index number 2 would be counted as our first point. Now, question is how we can use the shift node for creating such a form. For example, we can take this point and set it at the end of the row. This one, though, has been created using rest, where the first point has been removed. Now, although this is correct, we are still able to use the shift node for moving the point as I explained a few seconds ago. You know what, guys? It's better to say creating this form using the shift node is possible because it's not a 100% correct method. Why? Well, let's just find out why. By the way, guys, later on we'll be discussing where exactly we can use the shift node. So, back to the viewport. Okay, so I'm going to begin with setting a point in the viewport. Basically, guys, what I'm trying to do here is to help you understand the right way with somehow showing you the wrong way, or it's better to say less correct one, actually. I mean, this is what I want you to understand. I want you to understand, although shift kind of works, yeah, it's not the best way. It's not the best method. Anyway, so I'm going to connect this wire here. Then, give me another point. Same X value. And 6 units for Z. All right, let me increase this to 15. Okay, so first let's see what's going to happen if I set a simple line here. Let me connect the wires. There we go. This will be the result. Let's check up the lists that we got here, guys. The numbers. The first indices are these in both lists. I mean, the bottom one, the top one. Now, guys, I don't want this bottom one to be connected to this one. Instead, I want it to be connected to this one, to the second one. So, what I'm going to do would be giving this a -1 shift to move this index at the end of the row, or the list. And the second point would become our first point, in fact. So, shift. And for the amount, -1, as I said. What do you think will happen? I mean, by now you should know the drill. The second point in the previous list would become the first one in the new list. After the shift was applied, let me connect this wire now. As you can see, guys, this kind of works. Even if I change the amount to -2, again, it kind of works. However, because the points are being moved, the last 2 points on this side would be connected to these ones. Take a look at this again. Guys, try to understand them. Try to focus on them as much as you can, because these concepts are quite important. You know what, guys, to explain this a little bit more simple, I'm going to set the amount back to -1. Again, guys, previously this point was our first point. Now it is set at the end of the list. So the last point from the top list, talking about this one, would be connected to the last point in the new list, which previously was the first one, in fact. Now this creates a new problem. This line is extra. We don't want this. What should we do then? Guys, the thing is, the last item that we have in this list, the last item here creates this line. We need to remove this. So, I'm going to do another right click and search for remove. Here, remove item. Connect this wire. Then right click, count. I'll connect this wire. Then I need an equation, so give me a code block. Inside the code block, I'm going to type down a -1. Connect this wire and connect the code block to this port. See, it worked pretty well. Guys, my point here is we are able to complete a process using several nodes, but we need to know which one is correct, which one works the best. This was exactly the case here. Instead of using Shift to relocate the points, we removed one. In other words, we tried 2 nodes to find out which one works the best. Now right-click, rest, connect this to remove it. Now connect this to our lines port. This would be another awesome technique that we can use, guys. The other one would have worked too, we just would have gotten a longer code, guys. Alright guys, now as I promised, let's see where exactly we can use the Shift node. I mean, what is its correct usage? Well, we could be using it in similar shapes and forms to the one that we just saw. However, the form should definitely be a closed boundary. As always, to elaborate, we're going to go through some further examples, and we're also going to compare the result with the rest node. Let's say we got a circle here. I'm going to use translate now. Set another circle above the one that we already have by 3 units. This will do. Now, I'm going to add some points to these circles and then try connecting them together diagonally. For doing so, I'll be using this node called Point Add Parameter. This one. Obviously, I have 2 circles, so I need 2 nodes. We got the same amount. Now, I need a specific equation for the closed boundary shape. So it would be from 0 to 1 minus, set this parenthesis, inside the parenthesis, 1 divided by n. And then at the end, hashtag n. Now connect the formula to both of the parameter ports. Next up, I need an integer slider, which I'm going to set here. So again, what's the difference, guys? Before we had 2 parallel lines creating 2 rows, we can say, and here we got 2 parallel closed boundaries. Now, if I just go ahead and use a line node to connect the points, the connection in between them would be completely parallel, because all the points are simply being connected to the ones in front of them, exactly in front of them. However, I want the connection to be diagonal, like this point should be connected to this one. Well, you might be thinking of rest, so let's try that. For the top one, remove the first point, and create the connection. As you can see, we got the diagonal connection. Is it correct though? Well, no. For one simple reason, in closed down boundary shapes, we can't remove a point. I mean, as you can see, we're missing a connecting line here. So in this case, instead of removing the points, we need to be relocating them. And well, we won't be getting any extra lines or anything. So although the rest node worked pretty well for our previous example, we can't be using it for this one. So as I said, we need to use the Shift node. Let's activate the command. Set the node here. As for the amounts, we can go with either 1 or -1. Only the direction would be different. So I'm just going to go with 1. Let's open up these lists and see what exactly is happening. The first point and the top list, rather the bottom list, sorry. The first point would be this. Normally, it would be connected to this point. And when we apply the Shift, it would be connected to this one instead, which is exactly what I want. Now, obviously, the last point should be this. Right, so let's test this idea. Let's check the result. Perfect. No extra lines, no straight lines, and everything seems perfectly fine. So again, the first point here was moved to the end of the list. And well, the last point would be this one. In other words, this was the first point, and this point was in front of it, and then this was moved to the second place, and the last one was relocated to here. And the result was this beautiful diagonal connection. So overall, guys, in order to create such connections in between closed boundary shapes, we need to be using the shift node. Oh, and by changing the amounts, like by increasing it, the form gets even more interesting, even more complex, we can say. Oh, and while we're discussing changing the form, let's go ahead and use an integer slider here. I'm going to go ahead and use this handle, and as you can see, the form changes like this, and this is awesome. So you guys, this is a very interesting geometrical form that we created using the shift node in Dynamo. I'm going to leave the number on maybe this. Yeah, this will do. Alright guys, so we saw where and when exactly we can use the shift node. We saw what we can do using it. We also compared its result with the result that we would have gotten out of using the rest node. And now we can move on to our next discussion, where we'll be discussing how exactly we can volumize the lines that we would create in Dynamo. And I'm talking about all types of lines, guys. For example, these lines here could be converted into cables or, basically some other types of profiles, whatever we can think of. All right, everyone, let's begin our new discussion. The node that we'll be using for this process is called the sweep node. Now, you might already be familiar with the concept of sweep, guys. Basically, sweep is a tool which creates volumized forms. It has a path, and this path could have any kind of shape to it, like it could be a curved path, it could be a rectangular one, it could be a straight one, anything. And it also has a profile. Let me set its node, and then we're going to discuss it further. Now, the sweep node kind of works like extrude. I mean, it has both surface and solid. Surface as in an open boundary shape, and solid as in a closed boundary. Take a look at the image that we have on the right, guys. This is what I mean by surface. And then down here, we got sweep as a solid. Well, again, you can see its image, and based on what we need, we can use either one. Now, the form that I have in mind is close to a cable, so I'm going to go with solid. All right, guys, take a look at the ports that we got here. As you can see, we got the path on which we're going to set the profiles. For the path, I'll be using these lines. All right, so let me connect the wire. Now, for the profile, guys, we got a port called curve, as you can see. The profiles are going to be set and also move on the selected path. And well, the profile could also be anything. Could be a circle, a rectangle, anything. The essential point that we need to consider is that the profile should be perpendicular to the path. I might be saying, what if it wasn't, though? Well, fair enough. Let's see what's going to happen. I'm going to try setting a profile on a path, but I'm going to do so non-perpendicularly. Let me find the bottom points. Oh, there they are. I'm going to search for circle. I'll be adding this circle node here with a very small radius, like 0.1 or even less. Each line has a circle. I'm going to connect this wire. Now, take a look at this, guys. It worked. I mean, the form is volumized. However, instead of a circular form, we got an ellipse shape, guys. Let me zoom in on them. Guys, the reason that this happened is the fact that the circles weren't set perpendicularly to or on the lines. Now, don't get me wrong, though, guys. You might actually want this shape. If this is the case, well, congratulations, you have what you wanted. So, I guess what I'm trying to say here is that this shape is incorrect in case you wanted a completely circular form. Why is it incorrect again? Because the profile is not perpendicular to the path. Now, more important question, how we can set a profile perpendicular to a path in the first place? Let's find the answer together. Guys, the first thing that we need for meeting such conditions would be a plane perpendicular to the lines or to the paths. And then we can set our profile in that plane. So again, first and foremost, we need to set a plane perpendicular to these lines. There's a node that we can use for that, and a useful one for that matter, and it is called plane add parameter. If you recall, previously we talked about a node similar to this one, point add parameter. That node would have given us a point based on a defined parameter, based on a parameter that we would have defined in between 0 and 1. More specifically, a point somewhere on a line. Now this node kind of works the same, guys. I mean, as you can see, we got the same parameter port, which gets the same value, from 0 to 1. Though instead of a point, we'll get a plane perpendicular to the line. That's why we even got a similar name here, guys. Talking about curve.plane as parameter. So it's kind of similar. I'm going to connect this line to my curve port. Now, currently, as the plane, we got the base point, we got 0, see? If I try changing this, for example, I'm going to set this code block and go with 1. If I set this wire, connect this wire, the planes would be set at the end. Now guys, this might be a little bit confusing, so let's go through another example from the scratch. I want to hide these. I'm going to go through, let's go through a more simple example, guys. Maybe like a simple line or something. For example, give me 10 units here, both X and Y parts. And then give me the line node. Now I want a plane perpendicular to this line. What is the node again? Plane add parameter. Set the node here, then connect the line to the curve port. The result would be a plane perpendicular to the line. Now the plane is set right at the base point because the parameter's value is set on 0. If I change this to, let's say, 0.5, the plane would be set at the midpoint. And if I go with 1, the plane would be set right at the end point. Now again, it works quite similarly to point add parameter. The only difference is that instead of a point, we'll get a plane. In the previous example, talking about this one, the number of planes were a lot. That's why it was a bit confusing. Let me do something else then. Let me point out a single one here, guys, to show you what I'm talking about. If I select one, as you can see, right at the end points, you would be able to see these planes. Okay, so we got the plane. Now we need to set a shape or a profile on that plane. How we can do that though? Like if I go ahead and try setting a circle, the ports, as you can see, would be a point and a radius. So what we can get from all of this is the fact that we can use, we should be using another node. Let's not change the shape. For the circle, the node that we can use is called circle by plane radius. This means that instead of a point port, we would have a plane port. Obviously, this is exactly what we need. So I'm going to select by plane radius, connect the plane, and then a very small radius. Now, let me zoom in on the form. As you can see, all the circles are completely perpendicular to the lines, guys. And we don't have that ellipse form anymore. These are completely circulars. Let me hide this real quick. If I go ahead and set this on 0, the circles will be set down here. And by the way, guys, when we are using, so if we either go with 0 or 1. And yeah, guys, that would be all actually. We're done basically. Just connect this wire to our sweep node. Now, again, let's zoom in on the forms. As you can see, they are completely circular. So guys, this would be how to volumize the forms in Dynamo using the sweep node and plane add parameter. Alright guys, now let's try another profile. For example, a rectangle. And well, as you already know, rectangle is a plane-based form. So I'm just going to use these values to create the plane. And well, after we're done, we can just easily connect our rectangle node to our sweep node. Done. We also have the same thing for ellipse, guys. See? Ellipse by plane. So yeah, if you wanted to, you can easily set an ellipse as your profile. Alright guys, now we're going to talk about another node and then maybe another example, and after that I'll be giving you some practices or some tasks to do as well. Alright, so the last node that we'll be discussing today, let me use these circles. Okay, the node that we're going to talk about is called patch. Guys, using patch, we can convert a solid form into a surface. To put this simply, it converts a closed boundary shape into an open boundary one. So it's not really that complicated. Let me see what we can do for the example. Let's say we got this form here. Okay, let me just use another circle node here to complete this form. Now, what I want to do would be creating two surfaces or two faces in the top and bottom. Alright, so the node that I'll be using for this is called patch by patch. We're going to have the same thing in Rhino, guys. I mean, in there we would also be able to convert a solid into a surface. So, just select the node and attach the wire. It is quite simple. Now, we got two circles here, but we still want to use a single patch node. So, what should we do? Come on, give me an answer. Yes, we need to create a list here, guys. Again, answer the questions that I'm asking you guys. This is very important. Alright, so basically create the list, and then set a single patch node. Connect the wire. All done. Alright guys, in this session we're going to talk about scale. For example, let's say I want to set a circle here and I want to control its scale. Let me show you what I mean. I'll be setting this circle here. Now right click and search for scale. Now, in between the scaling items, or well, nodes that we have here, we're going to use this one. This node would give us a factor based on X, Y, or Z course, and then using that factor, we would be able to control the scale of our forms, and the forms could be either 2-dimensional or 3-dimensional. Now, we also have other types of nodes that we can use here, for example, based on a plane based on X, Y, and Z courses. Now, these ones are related to vectors, guys, and we shouldn't be using them because we need the ones that we could use in geometrical forms. Take a look at the ports that we have. Again, we have a geometry port, which, as I said before, it could basically be any form, any shape. Like, most specifically, it could be a curve, it could be a combination of points, it could be a solid, a surface, a poly surface, and basically anything. How about the factors? The amounts. I'm going to go with a number slider, and I'm going to attach this to X. Now, take a look at this. By increasing the number, as you can see, the form will change accordingly. Let me reduce the maximum number, it's too much. Yeah, this is better. And obviously, if we reduce the number, the shape would be changed like this. Now, if I get a copy of this number slider, and set another node here, and then attach it to Y, scaling would be done on both sides. So it doesn't really have a crazy process to it, guys. Now, one thing that we need to know is that we are also able to work with sequence of numbers as well. Give me a code block. Sequence would be like this, starting from 1, then triple it, all the way to 5. And again, guys, this isn't something new. We've seen this before in previous notes. Basically, guys, when we're using sequence of numbers in nodes, it's kind of like we're using the node multiple times. Right, guys, now let's talk about a very important node. We can even say the main node of this session. Then we can practice it through working on some significant examples. The node that we'll be discussing, guys, is called intersect. Through using this node, we would be able to detect the intersections in between the objects. For example, in between a line and a plane, two lines, two forms, a line and a form, a plane and a form. Yeah, so basically we can use this node in such situations. Now, we got two nodes with this name, intersect and intersect all. We'll be using this one. Well, I mean, intersect all is not really useful for us here. So, select a node. And again, guys, although this is an important node, it's not a very complicated one. I mean, it has this geometry port, and I don't think I need to mention this again, but geometry could basically be anything, a line, a curve, a form, anything. After we selected or specified the first geometry, we need to be selecting the second one. So first object, geometry port, second one, other port. Now, let's work on an example. Let's say we have a form such as a cylinder, maybe. A cylinder that is being collided with some lines, you can say. So I'll be starting with setting a circle here. And then another one. Then give me a point. After that, an integer to move it upwards a bit. Integer slider. Connect this to Z. And then let's use the same value for radius, guys. Then I'll be using a loft to volumize this whole thing. First, I need to create a list. I'm not going to explain this again, guys. You already know how it goes. Now loft. And you know what, guys? Let's actually use both types of lofts. As solid and also as surface. Let's begin with surface, meaning we'll be getting an open boundary shape. Okay, now I need a line, guys. I'm going to set a line here, and I want the line to be collided with this form. What do you think will be the result, though, guys? Well, let's set the line here. I'll be using line by start point direction. Give me a point. Okay, what was the height? 3. So this time for the height, give me 1. What is this? Oh, I copied the circle node, sorry. I have to copy the point node. Yeah, this is correct now. For the height, give me 1. Now connect this node to the line. And then on the x-course, as for the length, 5. Because I want a collision here. This will be the result. Now, guys, obviously, we'll be getting a point where these two objects are being collided. To find that point, we need to use this node. First, set the geometry. The first one. And then the second one. And the result would be an intersection point. Now, guys, take a look at this. As you can see, we got this point here. What is this? Well, it's kind of like we have an image of this point, and we set the image on our surface. And to be honest, guys, this point would be quite important and useful for us in the practice on which we'll be working later on. So again, we used a line to set an image of this point on this surface. Now, let me explain this one more time before we start the practice. I used a line node to create a collision with this surface, and then I used the intersect node to find the intersection point, guys. All right, let's move on. I'm going to try rotating this now. I'm sure you are quite familiar with this node, guys, with this command. Next node that I need would be an origin node. I'm going to connect this wire, and then I need a Z vector. Okay, now a code block from 0 to 360. And also set an equation here, but we don't really need this for now. We open up this list from 0 to 360. If you recall, in the previous sessions, we talked about the equation that we should be using here, but again, we don't really need an equation for this example. Anyway, let's just connect this wire, and the result would be all of these intersection points, guys. To explain this, we can say that we have multiple images of this point on our surface. And this is somehow one of the few methods that we have for doing this, for setting an image of a point on the surfaces. Now, in the future, we'll be discussing why we even need such imaging process. For now, though, let's just focus on the intersection points and, well, finding them in between the objects. Now, we saw how we can find an intersection points in a surface in an open boundary object. How about a solid object, guys? How about a closed boundary object? There is a huge difference. See, the result is a line. It's not a point anymore. I mean, more specifically, instead of intersection points, we got intersection lines. Let me hide these to display this whole thing better. Guys, to explain this, because this is a solid object, we won't be getting a single intersection point. Instead, a line would move through the object. So guys, the result of an intersection in between a line and a surface would be a point, and the result of an intersection in between a line and a solid object would be a line. Now, instead of lines, how about two forms? What if we had two forms? Let me try to give you an example. Let me hide these real quick. You know what? I'm going to use the forms that we have here. For example, I'm going to extrude the circle that we have down here. I'll be using extrude as solid to get something like this, guys. Well, also I'm going to increase the height. Yeah, so let's say we have a collision in between this tube, this cylinder, and this form. What do you think would be the result, guys? Would it be a line, a point? What do you think it is? Well, the result would be another form. So we can get that the intersection in between two solid objects would give us a new solid object. Again, between two solid objects. What if this one was a surface, though? In other words, what if we had an intersection in between a solid object and a surface? What I'm going to do would be using a loft here as a surface, and then try to create another collision here. You know what, let me increase the size of this circle, guys. So, give me another node. The circle node, the radius, give me 2. Alright, so take a look at this. We've got a solid object, then a surface. As you can see, these two are collided. What do we get as the result? Well, the result would be another surface, guys. See? A new surface. Let's say an intersection surface. Again, let me hide everything and show you this surface. There we go. This is the surface that has been created through a collision in between these two objects. Right. Is there anything left, guys? Yes. What if we had two surfaces? I mean, as you can see, this is a solid here. I mean, the cylinder is a solid. What if both of these objects were surfaces? To show you what I mean, I'm going to use extrude as surface and try creating something like this. Okay, let me show you. See, both of these are surfaces now. Now, what are we going to get as the result of this intersection? We'll be getting a line, guys. An intersection line in between two surfaces. Alright guys, so let's go through the whole thing one more time real quick. Intersection in between a line and a surface would give us what? A point. Intersection in between two surfaces would give us a line. How about a solid and a surface? We'll be getting another surface. And out of a collision in between two solids, we'll be getting another solid. Alright guys, now I guess it's time to... there's another node that we can talk about, and after we're done with it, we can get into the whole practicing and going through different examples. Guys, let's say we got a geometrical form, such as this one. I'm going to go ahead and hide everything, guys, except for the last part. Right? Now, first off, what is this form, guys? It is a surface. It could have been a solid as well. Guys, if you are familiar with the Rhino software, in there we got a command called contour. Using this command, we would be able to set parallel lines through an entire form. How can we do the same in Dynamo, though? Should we just go ahead and use and set up several and multiple surfaces? Did you get the question, guys? Let me explain myself one more time. We said that there's a command in Rhino called contour, using which we would be able to set parallel lines throughout the entire height of a form. Now, the question is how we can do the exact same thing in Dynamo. For example, let's say we're trying to create a model of a structure or a building or something, and we are trying to specify the levels to create the levels and floors, and we don't have any level lines to help us do that. Alright, so let's talk about it. We got a surface here, and I want some lines. How do I get these lines? I need to intersect this surface with other surfaces. Now, there are a few techniques that I can go with here. I'm going to tell you one, and then I'll be telling you about the more correct one. Actually, the better one. For example, I'm going to set a circle here. As for the radius, give me 10. Then I can use patch to get a surface out of this. Then I can use translate to move the surface upwards to somehow create the required intersection to overall get the lines that I want. Now, guys, this kind of works, but there's something that you should know. We are able to create an intersection in between surfaces and planes. What kind of plane? Well, a simple one, like this one by origin normal. Basically, planes could easily be intersected with all the forms that we have, like surfaces, solids, lines, everything. Now, this method is easier, it's faster, and it doesn't really make our file heavy. And in addition to all of these perks, planes would kind of be invisible, you can say. So let me go ahead and set a point here. Alright, let me just hide this real quick. Okay, now, give me a code block from 0 to H. And as for the number, N. On the Z-axis. Now, for the height, I'll be using, where is it? This node here. Yeah. So connect this wire. Now, I'll be using an integer slider here to control the levels. Connect the plane. Now, take a look at this. See, guys, we created many planes here, and all of these planes could easily be intersected with anything that we want. Let me unhide my form, the surface. Take a look at this, guys. By the way, don't mind the size, don't mind the graphics. Yeah, basically, after we're done setting the planes here, we can go ahead and set our intersect node. Again, don't use intersect all. Now, the only thing that we need to do would be connecting these two nodes to our intersect node. And as a result, we'll be getting all of these intersection lines, which is quite the same. Quite similar to what we would get in Rhino. Now, guys, just as you saw, the planes that we worked with in this example were flat ones. And well, just as easily, you can create diagonal planes. And for that, you just need to use vector 2 points node. Guys, all the intersection points and methods and modes that we talked about in this session were extremely important. So I actually recommend going through all of them at least one more time. I mean, like try testing and creating different intersections in between different forms until you'll learn everything completely and you'll become completely predominant in this whole thing.